Okay, this is the second video of the videos showing you the development of the peritoneal with the peritoneal model. We're going to show you the embryological development of the peritoneum in 3 steps. The rotation of the stomach and the duodenum, the rotation of the intestines, and the bulging of the greater omentum. In fact, these 3 steps overlap each other, but to make it easy, to make it clarify it, we separated this in separate steps. So the first step is rotation of the stomach and the duodenum. You must imagine that originally the stomach was a long tube, just as the rest of the gut tube, but it's already formed here because that was impossible to do different in the model. But you must imagine that at a certain moment the backside of the stomach elongates and thereby forms the greater curvature, and the front side of the stomach retracts, decreases, becomes shorter in length, and thereby becomes the lesser curvature. And because of this form change in the stomach, also the duodenum is drawn in its characteristic C shape. And this complex happenings developed the stomach and the duodenum into the well-known S form. Well, that's the first step, and then more or less simultaneously the stomach and the pancreas and the duodenum start to rotate around their axis. And what happens is like this. And now what has happened, you see that the stomach and the duodenum and the pancreas, they have rotated to the right side and they attach to the back wall. And then we call them, from that moment, we call them secondary retroperitoneal. That's because the intestine and the pancreas first was covered by peritoneum, so was intraperitoneal, but now it has attached to the back wall. It apparently seems as if the peritoneum, if you would imagine that it runs on, it's difficult to make a distinction, not in this model but in reality. So it seems that the peritoneum runs over from the back wall to the duodenum, but because it was intraperitoneal first, we call it secondary retroperitoneal. The fact that this duodenum and the pancreas adheres to the back wall is used by surgeons. They can easily detach again this duodenum and the pancreas and thereby reach the back of the pancreatic head and the duodenum. So in this way surgeons use the embryological knowledge. Also you see that a cavity has arisen behind the stomach, the so-called omental bursa. In fact, there's a large hole here, but that's because it's a model. In fact, it's only a very small access way that I can reach by hooking my finger around the hepatoduodenal ligament, and then the opening into the omental bursa, where I'm with my finger now, is the foramen omentale, or the omental foramen, or the foramen of Winslow. And so I can enter the omental bursa, and the omental bursa arose because of the rotation of the stomach.